Have you ever noticed that? You're walking through your office, and some doors are super light, but then others, maybe the ones leading to a stairwell, are just really heavy, and they always swing shut right behind you. So what's the deal? Well, I promise it's not a secret office fitness plan. It's actually a clue to this hidden system of protection that's all around you. And that hidden system is basically an invisible shield. It's a whole fire safety strategy that's built right into the structure of the buildings we use every single day. It's a complex set of rules that turns concrete, steel, and glass into a life-saving machine. So let's pull back the curtain and see how it all works. All right, here's our game plan. We're going to start with the official rulebook itself. Then we'll trace the layers of protection it creates, kicking off with the most important one, your path to safety. We'll look at how buildings are designed to literally box a fire in, how they stop it from spreading outside, and finally, how they're built to give firefighters a crucial helping hand. By the end of this, you're going to see this code everywhere. So, first things first, the master plan. You know the safety features you see in a building aren't just random add-ons. They're all part of this carefully thought-out strategy, a rule book that every architect and builder has to follow to keep us safe. Here in England, that rulebook is called Approved Document B. It's basically the government's official guide that takes the legal requirements for fire safety and turns them into practical, real-world instructions. Think of it like the assembly manual for building a safe building. It doesn't just say, hey, make it safe. It tells you exactly how. So the number one priority in that rulebook, Requirement B1, is all about you. It has one single focus, making absolutely sure that if there's a fire, everyone has a clear and safe way to get out of the building, period. The official term for this is means of escape. And the key word to latch onto here is structural. This isn't just about putting up a few exit signs. It means the escape route is physically baked into the design of the building. It's a protected tunnel, really, designed to hold off fire and smoke just long enough for you to get out. And this path to safety has 3 essential stages. First, you need that early warning. That's your fire alarm, right? Second, you need a safe path to travel through the building. These are the protected hallways and stairways that are shielded from the fire. And finally, you need a clear final exit that gets you all the way outside to a place of safety. And this brings us right back to our heavy door. See, a standard door is just a door. It's for privacy. But a fire door is a piece of engineered safety equipment. It's heavy because it's packed with fire-resistant stuff. That self-closing arm makes sure it's never just left open by accident. And get this, those special seals around the edge, when they get hot, they actually swell up and seal the gaps to stop smoke from pouring through, and smoke is often the real killer. That heavy door is literally holding the line, protecting your escape route. Okay, so you're on your way out safely. Now the building's next job is to start fighting back by containing the fire. This is where requirement B3 comes in, and it's all about stopping a fire from spreading through the inside of the building. The main strategy here is something called compartmentation. The best way to think about it is like the watertight bulkheads on a ship. If one part gets a leak, you seal it off so the whole ship doesn't sink. Fire compartments do the exact same thing for a fire. The building is divided up into these fire-tight boxes using special walls and floors designed to trap a fire inside one of those boxes for a set amount of time. And the code itself is super direct about it. The goal is pure separation. This one simple line is one of the most fundamental ideas in all of fire safety design. It's what makes sure a fire in one small part of a building doesn't automatically become a catastrophe for the whole place. So where do you actually see this in the real world? Well, the rules are really specific. For any building that's over 30 meters tall, every single floor has to be its own separate fire compartment. If a building has a basement, the ground floor above it has to be a compartment to stop fire from spreading up or down. And if you're in a big shop, over 2,000 square meters, it can't be one giant open space. It has to be broken up into smaller, containable compartments. All right, so we've got people out and we've boxed the fire end. But what about the outside of the building? That's where requirement B4 comes in. It's designed to stop a fire from leaping from floor to floor up the outside of a building, or even jumping to the building right next door. This means the building's skin, its external walls, its cladding, its roof, it has a 2-part job. First, it has to prevent a fire that breaks out of a window from just climbing right up the face of the building. And second, it has to act like a shield, protecting the building from a fire happening at its neighbor's place. This is a real puzzle for architects. They have to think about how close the building is to its neighbors. The more space they have, the more windows they can probably use. They have to pick outside materials like cladding and insulation that perform well in a fire. And they have to carefully calculate the size of any unprotected areas, like windows, to limit the risk of a fire spreading out. And now we come to the final layer of protection. This one isn't really for us as the occupants, it's for the pros. Requirement B5, make sure that when the fire service shows up, the building is ready to help them do their job as safely and effectively as possible. So the building itself provides a kind of toolkit for the firefighters. This includes stuff you'd probably guess, like access roads that can actually hold a fire engine. But it also includes built-in gear, like fire mains, which are basically internal pipes they can plug their hoses into, and specially protected shafts with reinforced stairs and lifts that are designed to be used during a fire.
And here is a number that really matters: 18 meters. In the UK building regulations, this height is a huge deal. As soon as a building has a floor that's 18 meters off the ground, that's roughly 6 stories up, it triggers the need for these dedicated, protected firefighting shafts. It's basically the point where it becomes totally impractical for firefighters to haul all their heavy gear up the normal stairs.
So we've seen how all these rules on paper get translated into the physical world that's all around us. These aren't just abstract ideas. They are real, tangible safety features that literally shape the buildings we live and work in every single day. And this is how it all stacks up into a layered defense. Different parts of the building have to hold back fire for different lengths of time. A fire door on a corridor might be rated to give you 30 minutes of protection to get out. A compartment wall separating 2 offices might need to hold for 60 minutes. And a supercritical structural wall in a tall building might need to provide 120 minutes of resistance, giving everyone time to get out and for the fire service to get the situation under control. But here's the final crucial point. All of this brilliant design, the heavy doors, the strong walls, the alarms, it all depends on one thing: people. The entire code is written with the assumption that the building will be managed properly. That means fire doors aren't wedged open, escape routes aren't cluttered with storage boxes, and all the safety systems are actually tested and maintained. The design is only half the story. So the next time you push open one of those heavy doors, you'll know exactly why it's there. You're not just walking from one room to another, you're moving through a piece of an invisible, life-saving system. This fire safety code is written in the very walls around you. And now that you can read it, what are you going to see?